Welcome back, dear students, to video number 2 for Standard 7 Science. We are discussing chapter number 14, Elements, Compounds and Mixtures. This is where we stopped in the previous video. We were discussing how matter is divided into pure substances, impure substances. So, have a look at this. We were discussing matter and we saw what are pure substances. Now, in pure substances, we are going to discuss what are elements. I will repeat again, pure substance is a substance which is made up of only one constituent. So, under that, there are elements and compounds from which we are going to study what are elements. So, let us begin. If we take some water in a teapot and heat it, the water droplets collected on the inside of the lid of the teapot are formed by the condensation of water vapor. Water in the form of vapor is composed of extremely tiny particles and therefore we cannot even see them. If we take some water in a spray pump and observe it, we can see that the spray is also composed of small particles of water. Similarly, all substances are made of extremely tiny particles. This is a picture. Have a look at it carefully. Look over here. These are the smallest unit of a substance and it is called as a molecule. What is the smallest unit of a substance? Means if we take a substance, again I'm taking the example of chalk. So if I take chalk and I keep on making pieces, I will get fine powder form. Again I keep on making pieces till I get the smallest form of that chalk. So that smallest form of the chalk is called as a molecule of chalk. Now my dear students, molecule again are of two types. See, one where whatever rounds or whatever things are connected, they are of the same kind. You see this orange colored and purple colored, they are of the same kind. And another kind of molecules where they are of different kinds. You see this? These are of two types. So, and if I separate these kinds, then I get something known as atoms. So, molecules can be further divided into atoms. We will study why these are called as atoms and why they are called as molecules. Molecules, my dear students, can exist independently, means they can survive on their own. Certain atoms can survive on their own, but certain atoms they cannot. So they need to join and combine. Hence, they join and they form molecules. So you see this orange colored, it cannot stay alone. It cannot stay independent. So it is joined with another orange colored and it has formed a molecule. So that is difference between atoms and molecules. Let's go further and see what are elements. So the smallest of particles of substances are molecules. Just now I showed the picture of molecules to you. A substance whose molecules are made of one or more atoms which are exactly alike is called an element. Now pay extreme attention to each word in this particular sentence. It is of utmost importance. A substance whose molecules are made of one or more atoms which are exactly alike is called an element. So over here, my dear students, These are molecules of substances. From here, which is an element? Yes, this particular orange colored and this particular purple color, this is an element. Why are these elements? Because according to definition of element, an element is a substance whose molecule has atoms. Now see, this molecules has atoms. This is an atom, this is an atom, this is an atom, this is an atom. But the atoms are of one kind only. So this orange is a molecule of an element and this purple is a molecule of another element. But can I call this as an element? No, because it is not of one kind. It is made up of different kinds. Can I call this as an element? No, this is again not an element because again it's made up of different kinds of atoms. So once again we'll continue. I'll repeat, a substance whose molecules are made of one or more atoms which are exactly alike is called an element. The smallest particle of elements are made of only one type of atoms. Now we cannot see atoms with naked eye, but when crores of atoms come together, their total volume is large enough to be visible to our eyes. We do not get different substances by decomposition of an element. Means if I take a top, I keep on dividing it, I keep on making pieces of it and say, can I get a different substance out of it? Or if I just do some reactions of it, if I take, let's say, a better example would be gold. I take gold, I melt it. Do I get a different substance? No, I get molten gold only. So we do not get different substances by decomposition of element because they are in the purest form. The mass and volume of atoms of different elements are different. Means the mass and volume of gold element and the mass and volume of oxygen element will not be the same. They are different elements, so their mass and volume will be different. Now let's take an example of oxygen. Oxygen gas. Oxygen occurs in nature in gaseous state. Oxygen is an element. Okay. Two atoms of oxygen are joined to form a molecule of oxygen, which has an independent existence. That means the smallest unit of that particular oxygen will be a molecule of oxygen. And how does it look like? Something like this. You see this? This is a molecule of oxygen. And why is it shaped like that? Because it has two atoms of oxygen. So, oxygen element exists as a molecule of oxygen which has two atoms of oxygen and the symbol is O2. You will study about this in higher classes. Why this is written like that? It is known as a bond. Shows a bond. You will study about it later. So, two atoms of oxygen are joined to form a molecule of oxygen which has independent existence. Oxygen in air is always in molecular state. So, you will in air, if we try and we take some air and we study it, we will find molecules of oxygen. Okay. Just like atoms, molecules also cannot be seen with naked eyes. That means there, when crores of molecules come together, only then you will be able to see them. In this case, you won't be able to see because it's in gaseous form and oxygen is, so it does not have a distinctive color or something. So you will have to observe it under certain um, instrument with the help of certain instruments. Now, in day to day life, we use short forms in many places. A similar method is used to indicate elements. The scientist J.J. Berzelius was the first to use the present method of using symbols for elements. The symbol of an element is written in the English script and is the short form of its name. Some elements and their symbols are listed in the table alongside. When the initial letter in the name of two or more elements is the same, a pair of letters is used to write the symbol. For example, we write capital C for carbon and capital C and small l, that is Cl, for chlorine. Now have a look at this table. There are more than 100 elements found in nature, and a few more were discovered or found out, or scientists made them in laboratories. So you will study about the entire all the elements and the periodic table in higher classes. Some of them are mentioned in this table. The first one, my dear students, is hydrogen and its symbol. Why do we write symbol? Every time we use these elements, it is not possible to write hydrogen chloride or hydrogen sulfide, or so we have certain short forms. So we use, if I want to say hydrogen chloride, instead of writing entire word hydrogen and chloride, I will just say H and short form for chlorine, Cl. So what is hydrogen chloride? HCl. So symbols make chemistry easier. And who started using the present method? Scientist J.J. Berzelius. What he did is he took the element and used the first alphabet. So hydrogen is denoted by H. Now again, helium also has H. So what he did is he took that H and from the rest of the word he just picked out any one particular alphabet. In the case of helium, he picked up He. So helium is, the symbol is He. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These are a few. There are more than 100. Elements are generally classified. Now, elements, my dear students, are further classified. Are generally classified into two groups, metals and non-metals. We have studied the properties of metals such as malleability, ductility, conductivity of heat and electricity, density, luster, sonority. All these are properties of metals. The elements that do not show these properties are called as nonmetals. For example, phosphorus, sulfur, chlorine, these are nonmetals. And the elements that show some properties of metals and some properties of nonmetals, there are a few which show properties of both metals as well as nonmetals. They are known as metalloids. This is the third group of elements, and some of the examples are arsenic, silicon, selenium, etc. So I'll repeat, elements are further divided into metals and nonmetals. These are two general categories, and certain elements which show properties of both are known as metalloids. Now some interesting thing. Do you know the wire that we see in the electric bulb in our house is made of the element tungsten? Its symbol is W and is derived from its German name Wolfram. Similarly, the symbol of silver is Ag and gold is Au, and they are derived from their Latin names argentum and aurum respectively. Elements occur in solid, liquid, or gaseous state. Some metals are difficult to use in pure form. For example, pure iron rusts in iron. Pure gold is very soft and bends easily. The properties of the original metal can be modified by mixing one or more elements in it. Such a mixture of metals is called an alloy. Brass, steel, 22 karat gold are a few examples of alloys. So, what have we studied up till now? We discussed what are elements, how they are made up of only one kind of atoms, and we saw a few properties, and we discussed how the elements are given symbols, etc. We will stop here. We will meet in the next video. Till then, thank you for watching. Have a nice day.